In the last class, we derived expression for characteristic impedance from its definition, that is Z naught equal to what? V naught plus by I naught plus, or else minus V naught minus by I naught minus. From that we have Z naught equal to what? That is under root R plus j omega L by G plus j omega C. In today's class, we will derive input impedance of the transmission line at any point on the line. Here we can write Zin as what? Vin by Iin. Now let us see what is Vin and Iin. Generally, transmission line is used to transmit the signal from source to load. Here this one is source having a impedance of Zs, and this one is load having a impedance of ZL. Generally, this transmission line is used to connect this load and source to transmit the signal from source to load. Here we have location. This is known as input location. This one is known as output location. Output is connected to the load and input is connected to the source. Here, this is what Zin. This location is x equal to 0. This location is x equal to L. At x equal to 0, what about the voltage? V equal to Vin, and current can be taken as Iin. At x equal to L, what about the voltage? V equal to VL and I equal to IL. Now by using this x equal to 0, x equal to L concepts, we can derive this Zin. Zin is what? Vin by Iin. What is Vin? Vin is nothing but the voltage at x equal to 0 on the transmission line. And Iin is nothing but what? I at x equal to 0. We know that V of x is equal to what? V naught plus e to the power minus gamma x, V naught minus e to the power gamma x. Similarly, I of x, we can write this one as what? 1 by Z naught into V naught plus e to the power minus gamma x minus V naught minus e to the power gamma x. Since Z naught equal to what? V naught plus by I naught plus, or else it is what? V naught minus by minus V naught minus V naught minus by I naught minus. By using this, we can write I of x like this. Okay, what you required? Zin. What is Zin? Vin by Iin. Vin is what? V of x equal to 0. Iin is what? I of x equal to 0. Therefore, Zin is equal to V of x equal to 0 divided by I of x equal to 0. Let us substitute x equal to 0 in voltage and current equations. Let us substitute x equal to 0 in voltage and current equations. We will get Vin and Iin. That is, if I substitute x equal to 0 in this one, we will get this one as what? V naught plus V naught minus divided by I of x equal to 0. Already we have I of x. That one is 1 by Z naught. Next we have to substitute x equal to 0 where you have x. This one gives what? V naught plus e to the power 0. That is V naught plus only. Minus V naught minus e to the power gamma x means x value is 0. This one is e to the power 0, which is equivalent to 1. 1 into this V naught minus, we will get this one as what? V naught minus. So numerator by denominator. Here this 1 by Z naught in the denominator. If you shift this one to numerator, we can write that Zin. We can write that Zin like this. Zin equal to, this one becomes numerator, that is Z naught into V naught plus V naught minus divided by V naught plus minus V naught minus. So this is what? Zin expression. What you required? Zin only. What you required? Zin only. So in order to derive Zin, we need to determine V naught plus and V naught minus. How we can find V naught plus and V naught minus? How we got this Zin like this? By substituting at x equal to 0. In order to get this V naught plus and V naught minus, let us go for x equal to L substitution. At x equal to L, V equal to VL. Therefore, VL equal to what? VL is nothing but what? V at x equal to L. That means V of x is this one. Let us substitute x equal to L. Then you will get V as VL. Then it becomes what? V naught plus e to the power minus gamma L. That means x is replaced with what? L. Then voltage becomes what? Voltage at the load. Similarly, this one becomes what? Plus V naught minus e to the power gamma L. I am writing this one VL as what? This VL can be written as what? IL into ZL. I am writing that one like this, that is IL into ZL, which is equivalent to V naught plus e to the power minus gamma L plus V naught minus e to the power gamma L. Let us take this as equation number 2, this one as equation number 1. Similarly, at x equal to L, I equal to what? IL. At x equal to L, I equal to what? IL. That means in order to get IL, I have to substitute x value as what? L in the expression of I of x. Then IL is equal to, therefore I am writing, therefore IL is equal to 1 by Z naught, V naught plus e to the power minus gamma x. Now x is replaced with what? L plus, no sorry, here it is minus V naught minus e to the power gamma L. Just as I substituted x value as what? L, then I got I as what? IL. So now I am writing this one like this, IL into Z naught, V naught plus e to the power minus gamma L minus V naught minus e to the power gamma L. So this is equation number 3. Equation number 3. For the space problem, I am removing this part. Now here equation 2 and equation 3, we have to get equation 1. In equation 1 what we have? V naught plus V naught minus. You have here V naught plus here IL into ZL. In equation 2 we have V naught plus V naught minus. Here also we have V naught plus V naught minus. Here it is positive side, here negative side. By adding and subtracting, we will get V naught plus and V naught minus. Let us go for what? Equation 2 plus equation 3 implies on left hand side what you have? IL into ZL. Okay, as we are adding, this one is IL into Z naught. We can take IL as common. We can write this one IL into ZL plus Z naught. As we are adding equation 2 and equation 3, this one and this one is same term. That means let us say this is x, this one is x. X plus x, 2x. What is this? V naught plus e to the power minus gamma L. That is equal to what? V naught plus e to the power minus gamma L plus V naught plus e to the power minus gamma L, which is equivalent to 2 into V naught plus e to the power minus gamma L. But what we require to get ZIN? V naught plus. Let us write the expression for V naught plus. That can be written as what? IL into ZL plus Z naught by 2. I am sending this to this side. We require this V naught plus only. Divided by e to the power minus gamma L. That divided by e to the power minus gamma L can be written in the numerator e to the power gamma L. So this is the expression for what? V naught plus. Let us take this as equation number 4. To get this ZIN, what you require? V naught plus, V naught minus. V naught plus is over. Now we require V naught minus. What is V naught minus? This one, here you have V naught minus in equation 3 and here also we have V naught minus. If I take 2 minus 3, then you will get this one, both are same, means cancelled as it is minus. Here plus minus of minus becomes plus. You will get on left hand side IL ZL minus Z naught, as it is plus ZL plus Z naught, as it is minus, here you will get ZL minus Z naught. That means IL is taken as common, we can write like this. And here this one cancel. Here this one plus this one, that is minus of minus plus. Here we got 2 into V naught minus e to the power gamma L. What you required? V naught minus. Let us write the expression for this V naught minus. So this V naught minus, send this term to this side. We can write IL into ZL minus Z naught. Send this to this side by 2. divided by e to the power gamma L. That divided by e to the power gamma L can be written as e to the power minus gamma L. That is V naught minus. Here we can easily remember this V naught plus and V naught minus. For V naught plus, what we have ZL plus Z naught by 2, that is plus. Here also e to the power gamma L, that is e to the power plus gamma L. Here also V naught minus, for minus ZL minus Z naught by 2, e to the power minus gamma L. IL is common. That means here as it is plus ZL plus Z naught by 2, e to the power gamma L, e to the power plus gamma L. As it is minus ZL minus Z naught by 2, e to the power minus gamma L. As it is minus, here e to the power minus gamma L. As it is plus, e to the power plus gamma L. As it is plus ZL plus Z naught by 2, V naught minus. Like this also we can easily remember logically. So these are what V naught plus, V naught minus. Substitute V naught plus, V naught minus in equation 1. What is equation 1? This one, the equation 1. So we can write now ZIN. Basically we require that ZIN only. Therefore substitute V naught plus V naught minus in equation 1. What is equation 1? This one. Therefore ZIN equal to Z naught into what is V naught plus IL ZL plus Z naught by 2 e to the power gamma L, that is V naught plus V naught minus, that is IL into ZL minus Z naught by 2 e to the power minus gamma L, that is V naught minus, divided by IL ZL plus Z naught by 2 e to the power gamma L minus IL ZL minus Z naught by 2 e to the power minus gamma L. So this is about substitution, simple substitution. Now if you see here IL gets cancelled. I am writing ZL terms and Z naught terms separately. Here Z naught, here it is ZL, here also ZL. So ZL remaining is what, e to the power gamma L by 2, and here ZL e to the power minus gamma L by 2 plus e to the power minus gamma L by 2. So that by 2 is common. Next Z naught terms, what are the Z naught terms you have? Here Z naught, that is e to the power gamma L by 2. Let us take it, Z naught as common, e to the power gamma L by 2. Here remaining is what, minus. As it is minus, here you have minus e to the power minus gamma L by 2. Similarly, here I am writing first Z naught term. Okay, you will understand why I am writing Z naught first. So here Z naught term, it is e to the power gamma L by 2, and here minus, sorry, it is minus into minus, that is plus. Remaining is what, e to the power minus gamma L by 2. Why I am writing Z naught as first term? Here you have e to the power gamma L plus, here also e to the power gamma L plus e to the power minus gamma L by 2. Similarly, remaining is what, ZL term, that is ZL. Remaining is what, as you take ZL as common, here remaining term is what, e to the power gamma L by 2. ZL, here it is plus ZL, here we have minus sign, because of that here that is minus ZL. Remaining is what, e to the power minus gamma L by 2. We know that this e to the power gamma L, e to the power minus gamma L by 2, e to the power gamma L minus e to the power minus gamma L by 2, which are equivalent to, basically this one is equivalent to sin h gamma L, sin h gamma L, and this one is equivalent to, this one is equivalent to cos h gamma L, cos h gamma L. That's why we can write ZIN as like this, that is Z naught into ZL. This one is equivalent to what, cos h gamma L, e to the power gamma L plus e to the power minus gamma L by 2 is cos h gamma L. That means positive is if they are added, that is cos, if they are subtracted, sin. Z naught sin h gamma L divided by Z naught, as it is plus cos term cos h gamma L, ZL as it is negative sign, it is sin term, that is sin h gamma L. So this is the expression for what, ZIN. ZIN equal to what, Z naught into ZL cos h gamma L plus Z naught sin h gamma L divided by Z naught cos h gamma L plus ZL sin h gamma L. Here we can take cos h gamma L as common. Remaining is what? That is Z naught. Here in the numerator and denominator, if you take in the numerator and denominator, if you take cos h gamma L is common, remaining is what here? That is ZL. Cos h gamma L as taken as common in the numerator and denominator, that will be cancelled. And here Z naught into sin by cos, that gives what? Tan. Z naught tan h gamma L divided by, as you take cos h gamma L as common, remaining is what? Z naught plus, as cos h gamma L is taken as common, this becomes what? ZL into sin by cos, that is ZL sin by cos gives what? Tan h gamma L. So this is the expression of what? Zin. Zin equal to Z naught into ZL plus Z naught tan h gamma L divided by Z naught plus ZL tan h gamma L. Once again, I am writing this derived expression here in terms of cos, sin and tan. Here we have what? This one, that is Zin equal to Z naught into ZL cos h gamma L, that is first term, cos term. After ZL, this one is Z naught sin h gamma L. We can easily write denominator term. Here you have ZL, that ZL can be replaced with Z naught. It is first term cos h gamma L. And after Z naught, this one is ZL, or else Z naught is replaced with ZL. Second term sin h gamma L. In terms of the tan, it can be written as what? Z naught. After Z naught, ZL. After ZL, Z naught. Second term tan h gamma L divided by, as it is ZL, we can replace ZL as what? Z naught. As it is Z naught, we can write this as what? ZL. Second term is tan h gamma L term. So this is about what? Input impedance of the transmission line. Listen carefully how we derived this Zin. First we have written Zin as what? Vin by In. What is Vin? That is V of x equal to 0 divided by I of x equal to 0. From this we got this one as what? Z naught into V naught plus V naught plus divided by V naught plus minus V naught minus. In order to find this V naught plus and V naught minus, we substituted V of x equal to L, which is equivalent to what? Voltage at x equal to L is nothing but what? Voltage at the load. So here we have written this one as what? IL into ZL. So for that we will get, by substituting x equal to L, we will get IL into ZL, which is nothing but VL, that is equal to what? IL ZL. We have taken this as equation 2, and this one is taken as equation 1. And similarly, I of x equal to what? L. By substituting this, we will get IL. That means at x equal to L, we will get what? I as IL. That is nothing but what? 1 by Z naught e to the power minus gamma L. V naught plus e to the power minus gamma L minus V naught minus e to the power gamma L. Here we can send this Z naught to this side. We will get IL into Z naught. IL into Z naught like this. IL into Z naught like this. By adding and subtracting, we will get V naught plus and V naught minus. By substituting V naught plus and V naught minus, we got the terms e to the power gamma L and e to the power minus gamma L terms. In that, IL is cancelled, and we have ZL plus Z naught by 2 e to the power gamma L term, and ZL minus Z naught by ZL minus Z naught by 2 e to the power minus gamma L. By separating ZL terms and Z naught terms, we got this type, this formation, that is e to the power gamma L plus e to the power minus gamma L. And another one is what? E to the power gamma L, e to the power minus gamma L by 2. These terms are equivalent to what? This one is equivalent to cos h gamma L, this one is equivalent to sin h gamma L. Finally, we got expression like this. And by taking cos h gamma L as common in the numerator and denominator, we got expression like this. This is all about the derivation of the input impedance of the transmission line. Once again, I am repeating, here Zin can be written as Vin by Iin. That means Vin means what? At x equal to 0. V at x equal to 0. Iin means what? I at x equal to 0. Similarly, VL means what? V at x equal to L. IL means what? I at x equal to L. By substituting all these, we will get V naught plus and V naught minus. And by substituting that V naught plus and V naught minus in the expression like this, we got cos h gamma L form and sin h gamma L. And by writing separate, by writing ZL and Z naught as separate, we got this cos h gamma L form, sin h gamma L form. And by taking cos h gamma L and cos h gamma L is common in the numerator and denominator, we got a form like this, that is tan H gamma L like this. So this is all about the derivation for the input impedance of the transmission line. I will ask one question for you. Suppose if I replace this one L as X, in that case I will get what? Impedance of the transmission line at any point on the line, that is Z of X equal to what? Z0 ZL plus Z0 tan H gamma X divided by Z0 plus ZL tan H gamma X. That means L is replaced with what? X. That means basically this is the expression for what? Impedance of the transmission line at any point on the line. Okay, we will meet in next class.